Assalamualaikum. My name is Muhammad Amrul Aiman bin Muhammad Zari. My matrix number is 20246533786. Chromatography is one of the most important analytical techniques used in forensic science. Chromatography is employed to separate, identify, and analyze chemical substances found in the evidence collected from crime scenes. The fingerprint and magnifying glass shown in the image symbolize forensic investigations, where scientists carefully examine physical and chemical evidence to uncover facts related to criminal activities. Through chromatography, forensic analysts can detect the presence of illegal drugs, poison, explosive, ink, dyes, and also biological samples with high accuracy and reliability. The principle behind chromatography is the separations of compounds based on differences in their chemical and physical properties. As different substances move through the chromatographic system at varying rates, they become separated into individual components that can be identified and compared with known standards. This capability makes chromatography a powerful tool in forensic laboratories because it produces reproducible and scientifically valid results that can be presented as evidence in legal proceedings. Therefore, chromatography serves as a crucial bridge between scientific analysis and criminal justice. Thin layer chromatography, also known as TLC, is a simple, rapid, and cost-effective chromatography techniques commonly used in forensic laboratories. The crime scenes image represented on the slides how TLC can assist investigators in the preliminary identifications of substances collected from crime scenes. Because forensic investigations often require quick screening of evidence, TLC provides an efficient method for determining the possible identity of unknown compounds before more advanced analyses are conducted. The technique consists of two main components, the stationary phase and the mobile phase. The stationary phase is typically a silica gel coated plate, while the mobile phase is a solvent that travels upward through the plate by capillary action. Different compounds migrate at different rates depending on their polarity and interactions with both phases. As a result, separated spots appear on the TLC plate, which can be compared with known reference standards. In forensic science, this process is particularly valuable for detecting drugs, toxins, and other suspicious substances, enabling investigators to make informed decisions during the early stage of evidence examination.
Hi, my name is Nur Aisha Umayyaddin PhD. My matrix number 20244439448. I'm going to tell you about the explanation on application. Thin layer chromatography (TLC) is used in forensic science as a preliminary method to detect and identify drugs. Drug compounds are separated on silica gel plate based on differences in polarity, causing them to travel different rates in the solvent system. The RF value obtained are compared with those of known standards to help identify unknown substances.
My name is Norahana Arisha Binti Jasni. My matrix number 2024221662. Now, I will explain the methodology used to identify an unknown drug sample using thin layer chromatography or TLC. First, a baseline was drawn approximately 1 cm from the bottom of the TLC plate. This line serves as the starting point for all samples. Next, standard drug sample and the unknown forensic sample were carefully spotted onto the baseline using capillary tubes. The standard are used as a reference for comparison later. The TLC plate was then placed into a developing chamber containing the mobile phase solvent. The solvent moved upward through the stationary phase by capillary action. As the solvent travels up the plate, the different compounds in each sample separate according to their affinity towards the stationary phase and the solvent. This separation formed the basis for identifying unknown substances in forensic investigations. After the solvent had moved close to the top of the TLC plate, the plate was removed from the chamber and allowed to dry. The separate spots were then visualized under ultraviolet or UV light to make them easier to observe and measure. Next, the distance traveled by each spot and the solvent front was measured accurately. Using this measurement, the retention factor of RF value was calculated for each sample. The RF value is obtained by dividing the distance traveled and the compound by the distance traveled by the solvent front. Finally, the RF value of the anode sample was compared with those of the anode standards. If the values match, the identity of the anode substance can be determined. This slide shows an example of TLC result obtained during the analysis. The paracetamol standard traveled 5.2 cm, while the solvent front traveled 8.0 cm, giving an RF value of 0.65. The aspirin standard traveled 6.4 cm and produced an RF value 0.8. For the unknown forensic sample, the spot traveled 5.2 cm and the solvent front traveled 8.0 cm, resulting in an RF value of 0.65. Using the formula RF equals distance traveled by the distance spot divided by distance traveled by the solvent front, we calculate an RF value of 0.65 for the unknown sample. Since this value matched the paracetamol standard, the anode substance was identified as paracetamol. This demonstrates how TLC can be used effectively to identify unknown compound in forensic investigation.
My name is Nurfarisha Ikma binti Rizwan. My number matrix is 20242791108. This case study shows how TLC was used to analyze ketum sample in Malaysia. First, ketum leaves were collected and submitted for forensic examination. The sample extract was then applied onto a TLC plate and developed using a suitable solvent system. Next, the RF value of sample was compared with the metragonite standard. A matching RF value indicates the presence of metragonite in the sample. This result provides preliminary evidence to support forensic investigation involving ketum-related substance. Now we are going to look at comparison between thin layer chromatography and paper chromatography. TLC uses silica gel or aluminium as the stationary phase, while paper chromatography uses cellulose paper. TLC provides better separation, higher sensitivity and faster analysis than paper chromatography. Due to these advantages, TLC is widely used in forensic science, especially for drugs and toxicology analysis. Therefore, TLC is generally preferred over paper chromatography for forensic investigation.
Looking toward for the future, thin layer chromatography continues to evolve and improve in forensic science. One important development is high-performance thin layer chromatography or HPTLC. This technique offers better sensitivity, accuracy and resolution compared to the conventional TLC. Another advancement is the use of digital imaging system. This system improves spot detection and provides more precise measurement of RF values, reducing human error. Automation is also becoming increasingly important. Automated sample application and scanning system can improve efficiency and consistency in forensic science laboratories. Overall, this advancement will make TLC faster, more reliable, and more cost-effective for drug screening and forensic investigation. As technology continues to develop, TLC is expected to remain a valuable analytical tool in forensic science.
To conclude, thin layer chromatography is a fast, reliable, and cost-effective technique. It provides a rapid separation and preliminary identification of drug within a short time. It also produces consistent and reproducible results when compared with non-standard and RF value. In addition, TLC requires minimal equipment and small amount of solvent, making it a low-cost method compared to advanced technique. Therefore, TLC remains an important tool in forensic drug analysis.
This slide shows the usefulness of TLC in forensic drug analysis. TLC helps identify unknown drug substance in forensic sample and support criminal investigation through preliminary drug identification. It also assists forensic scientists in comparing evidence with known drug standards. In addition, TLC can be used to analyze drugs found in biological samples and seized materials. TLC help uncover truth in forensic investigation by identifying unknown substance through scientific analysis. Thank you.